Hey robot makers, how you doing? Hope you're having a good day so far. So we've got a cool show for you today, all about how to build your own AI. So let's get to it, shall we? So this show, yes, how to build your own AI assistant using Python. So I'll give you an overview. This is going to be a series. We're not going to do it all in one session. There's quite a lot to cover here, but we're going to go over all the basics, all the stuff that you need to do to create your own. So we're going to look at how AI assistants work, what you'll need, adding AI skills, and what we can expect to achieve with those skills. I would say this is probably an intermediate level, probably not one for just beginners who are just getting into Python, because we'll be using some more of the more libraries and things like that. So yeah, I need a familiarity with Python, I would say. Somebody just asked as well, is this Python 3? Yes, it is. I think Python 2 went end of life at the beginning of this year, so definitely Python 3. So how are we going to create this AI assistant? So we're going to use a Raspberry Pi computer. So I'm actually using a Raspberry Pi 4. I have a Raspberry Pi 3, so this kind of small computer. The Raspberry Pi 3 does have an audio out, and we might need to use that shortly. We will need some other hardware as well to bring audio in. But we're using a Raspberry Pi. It will also work on the Raspberry Pi Zero, just not the Pico. The Pico has a microcontroller. So what we'll be able to make it do is we'll create code that will listen to commands. We will create code that says responses back to us. In any language, actually, it doesn't have to just be English. We will create a web interface so that we can create, we can check what it's doing from our mobile devices, from our laptops or whatever we want to use, iPads. Other products are available, and we'll be adding skills. So I like the idea in the Amazon ecosphere, whatever you call it, where they have skills. So they have additional things that you can bring in, and Python is really extensible, so we should be able to create some extra classes for specific skills and bring them in later on. So we're going to be looking at how we can do that so that our AI is able to connect to other web services and use those APIs, and we'll talk about what all those things mean as well. So Python, Raspberry Pi, we're going to do some cool stuff is the overview there. So let's get into it. How do AI assistants actually work? So here's a bit of a flow diagram. So they'll listen for some kind of wake word. If they hear that wake word, they'll then listen for a known command. And we're going to use something called Elasticsearch to help us with some fuzzy logic. Because if we had to create every single combination of command that somebody could say, so say we wanted to say, tell me a joke. It might be tell me a joke, or give me a joke, tell me something funny. I want to hear something funny. There's so many different ways of saying that we couldn't program every single one of them for every single thing that we want our AI to do. So that's where some of the artificial intelligence comes in, and we're going to use something called Elasticsearch. That's what I think. We're going to execute those known commands, and then we're going to get it to speak back the response, because this is going to be a vocal, auditory kind of AI. It's going to talk to us and talk back. In the meantime, it can do stuff in the background. So you can see there in that little diagram, it starts off, it listens for the wake word. Has it heard the wake word? No. It'll go background and it'll keep waiting until it has heard that wake word. Then, it will listen for the command. So we'll say something like, hey robot, and then it will say yes, and we will say, tell me a joke. And then it will wait till it's understood that command, it will execute that command, and then it will finish. Or it'll go back waiting for the next wake word, depending on what we want it to do. If it hasn't understood that command, it will wait for another command, and after some kind of timeout period, it'll go back to waiting for the wake word. So all these things we can build into our logic quite straightforward. So hey Noah, how you doing? And hey Stephanie, you're joining the stream as well. So that's one of my friends from the Live Streaming Pro community. So rather than just show you on this, I thought I would show you on the overhead as well, just how this is going to work. So just move my artwork out the way for a second. So let's get started here. So if we say this is our AI in the middle here, I'm just going to draw a little box around it. I have to make sure I speak into the microphone as well, because if I don't, you'll not hear what I'm saying. And then we've got our little friend over here, and he's going to sort of speak some text. He's going to say something like, tell me a joke. And what's going to happen is that's going to be some kind of waveform. It's not something that we can send to we can interpret ourselves at this point. We don't know how to interpret voice. So what we're going to do is we're going to use something like Google. Now we could use something on device, and we will look at other options like that further down the track. But what we want to be able to do is just get up and running quite quickly. So what we're going to do is we're going to send that wave file to Google, and Google is going to come back and it's going to give us the phrase that we're looking for. So it's going to say, tell me a joke, and that's going to be some kind of digital waveform thing. Send it up to Google voice services, and it's going to send back to our AI the phrase, tell me a joke, just as a text string. So that means it's very easy for us to get up and running. So hopefully that makes a bit more sense than just the flow diagram. Now, let's start with a sketch. So we've already started a bit with a sketch, and what I mean by that is, let's go back over to here. I just move these to one side for a second. What I want to achieve in this series is to create our own virtual assistant. So what do we mean by that? What is this AI? So we know that we want to do something with speech. So let's have our little speech bubble over there. That's going to communicate backwards and forwards, just as we've shown previously. We want to do something to do with skills. So what we will be using is something called application programming interfaces. And that's how we connect to things like Google Speech, or weather services, or joke services, or weather stocks. Let's write some of these down. So we've got weather. I thought that was quite a useful one. So you could say, tell me what the weather is today. Do I need an umbrella? That kind of thing. We might want to look at stocks and shares. We might want to look at news. Oops, I have terrible handwriting, as you can see. We might want to look at what is our calendar, what are we doing, and we might also have a to-do list. So we might have some to-dos on there. And I would say these are all skills. So these are things that we can develop and build upon later on. So that's going to be our skills. And I would also like to have, like I said, a web user interface. So we'll call that the web user interface. And that's another thing that we want to be able to communicate backwards and forwards. And we're going to be using some technologies which have been written specific for Python. And Adam's asked an interesting question there about will we be able to control SMARS as a skill? Absolutely. And this is the beauty of this. We can say move forward, move backwards, do a dance, that kind of thing. And whether it's a wheeled SMARS or whether it's a quad SMARS, we can get it to do all these kinds of commands. That's part of our skills framework, how we build extra skills onto that. So that's not Flash, it's Flask with a K, as in something you drink from. We will look at all these technologies a bit further on. So there's something called Markdown. We did touch on that a couple of episodes ago. It's a way of creating web pages, but with very simple text. We'll probably use something called Jekyll as well. And if we're using Python and we're doing stuff to do with the web, we will probably use Beautiful Soup. I've spelled this wrong, Beautiful. That's T-F-U-L, soup. And we also want to do some fun things as well. So let's have fun over here. And that's things like jokes. It's things like, when we were doing one of the first Python programs, I created a little insult generator. So we'll have some insults, and I don't know why, maybe something to do with time as well. Maybe you can get it to do reminders and stuff. And then one of the other things I thought, which is, it probably should be in the skills area over there, is home automation. So when we looked at things like Node-RED the other week, that's home automation using MQTT, that kind of technology. That's a skill. These are skills. And the web UI and the speech, that's going to be a core component of what we have. So we've got speech recognition, and we have speech synthesis. So synthesis, honestly. I did do a nicer version of that just there. Let's use that one instead. So that's our sketch. That's what we're trying to achieve. I thought I'd draw that out just so you can see the thinking of what goes behind this. So we want a core AI code, which is going to be a loop. We're going to go round and round that loop, listening for speech. We're going to be taking the actions. And we're also going to be presenting them via the web user interface and checking the web UI to see if there's any actions coming in there. We will be adding skills as we go. So like I said, home automation, weather, news, fun, all the rest of the things that we can think about. And you can add extra skills to this too. That's the really cool thing with this. So what is the architecture of this? So if I was to sort of beautify that drawing that we just looked at a second ago, we can see there's four main parts to this. We've got the speech engine where we can recognize and we can say things back. That's a lot easier to do than you would think in Python, whether you're using a Raspberry Pi, Windows or a Mac. And the code we write should work across all those platforms without any kind of tweaks or anything. The web user interface, like I said, is using something called Flask. Flask is a Python web framework, similar to things like, what's the name of the other one? My mind always goes blank when I do these live streams. Drupal, not sure if it is that one. Anyway, we'll come to that. We have an orchestration engine, and what we mean by that is just what is this loop that goes through and checks for commands, and we want that to be extensible, so when we add extra skills it can look to see what the extra commands these skills have, and then if you say one of them, how does it then go and delegate that to the skill to go and do. And we can see there we've got all these different APIs, these application programming interfaces. And what they are is, if there's a news site, say Yahoo News or Twitter or wherever we want to get our news from, we need to be able to sort of grab from that a list of things that are current and then present them back using our voice interface. Similar with a calendar, so if we say, what are the appointments? If you say to your AI, what have I got on today? It needs to go and check your Google Calendar and see like a list of events that are going on today and just summarize that for you. So that's what these different things are. They're going to be reaching out to a web service, grabbing some data and then sticking it back into the speech engine and then telling us what it is. So the home automation is MQTT. And the weather API, I was looking at Open Weather. That's a free service. I think you do need to register to get a key. However, it does work really simply and it gives you the weather. So we can build all these things into our AI. So we should be able to do that over the next couple of weeks quite simply. So how it's made, we need a speech engine. We need to write that. We can do that today. The skills class we will look at next week. The web user interface probably the week after. That's an interesting one if you've not used Flask before. You can build websites and build your own APIs very simply. Flask has got all that stuff covered for you. And even reaching out to other web services and bringing it back. They have things like JSONify where you can just make things magically transform to the right format for you. Then we have the orchestration engine, the loop, and the skills. So they are the different components that we're going to be building over the next couple of weeks. But we'll start today with the speech engine and the main loop, the orchestration engine. So if you like these videos, please make sure you like, comment and subscribe. That helps me understand through the analytics whether these videos are good, whether you want more of them. It's kind of crowdsourcing awesomeness because we get to find out what everybody wants. So if you can help me do that, that helps the channel grow as well. Oh, and just in case I haven't already mentioned, I do go live every Sunday around 7 o'clock-ish GMT or British summertime, whichever the local time is for me here. So I think this is 6 PM GMT actually at the moment. But they're the different three time zones that you roughly will fall into, either in the US and Canada on the left-hand column, the European, Pakistan, India, Russia kind of column in the middle, and China and Australia, New Zealand, all those kind of areas on the right-hand side. So yes, make sure you check out that. And then the website. So I run a website called smarsfan.com, and that's where I put all the information that are about Smars robots and any other robots that I'm currently building, such as the Pico Crab, which I've got just behind me over here. So yeah, check out smarsfan.com. And if you also want to help out the channel, you can always go over to buymeacoffee.com/Kevin McAleer and just buy me a coffee if you want. And that's going to help pay for the show and keep it running for another year. Okay, let's get back to our keynote presentation, shall we? So Marcel says, hi nerdy friends. Hi Marcel, how you doing? And so Noah says, so what wait word are you thinking of using? So I did ask in the community, in the small robots group that I run, what do people think will be a good name for a robot? So that's kind of where I was, that's where I was coming from. And somebody says it'd be great if you had more series of tutorials on microcontrollers and robotics. Cool, I shall make a note of that. So you want more microcontroller stuff. Microcontroller. And this is part of robotics, AI, because once we've built a robot, if it's just a box with servos and stuff, you want to make that more interesting and be able to respond to its environment. So building an AI is part of that, and that's why I wanted to do a series focusing on that. But we also have the midweek slots where I can shove some other videos out there as well. Marcel says, I think you're missing one Sharpie. I think you're right. I think there's another green missing, isn't there, from that collection there? Yes, I did order a few too many Sharpies. Okay, so we've covered the video. So what hardware and software do we need to build our AI? So for hardware, we're looking at Raspberry Pi. The reason I've chosen the Raspberry Pi is because it's a contained robot-sized computer, so we can put this inside a SMARS robot. If it's a Raspberry Pi Zero or a SMARS Quad or any other type of robot, an Auto DIY. But we've got the full power of Linux and the full power of Python inside that computer, so it's really powerful, much more powerful than say a Raspberry Pi Pico or an Arduino or an ESP32, and so on and so on. So we need that kind of power when we're doing some serious AI stuff. So Raspberry Pi, I would recommend the fastest you can get. So whether it's a Raspberry Pi 4, 3, 2, 0 or 400. 400 is the one that's inside the keyboard. Yeah, whichever you can get. But I would recommend that. You can run this code on any machine and it should work. So as long as you've got a keyboard, a mouse, a screen, a microphone and a speaker, you should be able to run Python fine. So you probably need a USB microphone. So what I've got here, I ordered this one yesterday. It was the cheapest one they had on Amazon. It's not a fantastic microphone, but it doesn't need to be for voice recognition. It just needs to be good enough that it can hear the text, hear the speech even. I did even order this tiny little one. I didn't even know they did them this size. So this is a tiny little microphone there. You can see I've got a Sharpie on my thumb there. And that little series of dots there, that's actually the microphone. Probably not the best quality. And it does work, so that one is an option if and I think that was probably about £1.50 or something. It was very, very cheap. And you'll need some speakers as well. So I bought some Trust speakers. Again, these were pretty cheap. They're USB powered, not very, very loud, but again, it's just enough that I could hear. I mean, you could even use headphones if you wanted to, or pump it into another sound system that you've got, but I've just got some cheap speakers there as well. So Raspberry Pi, USB microphone and speakers. Cool. So I've got some other comments there. I'll just cover these off just while we're looking at them. Kang is saying AVR programming would be great. Absolutely. So we'll do some AppMel stuff, 18 megas, Arduino type stuff. You like the British Paul McWhirter? Who's Paul McWhirter? I need to go and Google him. I'm just writing that down because I'm like, who's that? And then Philippe says, it would be great if you did more in-move content. Absolutely. So I actually started my whole robot building journey with an in-move. So you can see that's his torso and arm there. And just over there is his head. And what I found out, as well as being quite an expensive build to make, because the servos on that are absolutely huge, and some of them are about £40 each. Are the ones for the sort of arm, because it's lifting a lot of load, so it has to be a really strong one. But it was the actual Python and My Robot Lab software. I wasn't really happy with that. I didn't think it was a great piece of software. Just saying what I think, and I thought I need to learn more software before I continue this build, because otherwise I just end up with a full-size robot that doesn't really do anything, and I want it to be able to be intelligent in the sense that we're looking at today. So that's why I started with the in-move, and we will certainly be doing some more in-move stuff as well. Adam says the RPI, so the Raspberry Pi is an AIO SBC. All-in-one single-board computer. It absolutely is. I have several single-board computers. I was involved with a group of people who are converting the Chromium OS to Raspberry Pi a couple of years ago. A guy called Dylan. And we looked at all kinds of single board computers. There's one Rock 64, I think it's called. So I have one of those as well. I've got a whole collection of them. And Lunos FPV says, "Sweet Kevin, thanks for doing these videos, you rock, and wiring up my Pico Smiles. Awesome." Good, good. So you said, take it you've missed the RPI speech assistant Magpie giving away some years ago. I have one of those in my drawer. So just back over here, I do have exactly that. So this was the unit that he's talking about there, which is it's a Raspberry Pi powered voice assistant with an arcade button there. And inside is like a special voice circuit, and I think that's a bit of a cheat. You can do it all in software. You don't really need any special hardware. And this is made of cardboard, which isn't fantastic. It does have a speaker in, does have the amplifier and all that kind of stuff. Isn't battery powered, and you do have to press to talk, which we don't on ours. We can get ours to be more natural. So I'll come back to the comments a bit later on, and we'll just continue on with the presentation bit here. So what software we're going to be using? So I did mention before Flask, which is this funny sort of leather flask horn thing, and that's a web framework toolkit for Python. So that can help us create APIs, web pages, all that kind of stuff. Paired with that is Bootstrap. So Bootstrap is a way of being able to bring in all formatting and CSS cascading style sheets to your web pages and make them look beautiful with very little code. And they take away a load of the headache that would be associated with building a website. So smilesfan.com, for example, is built using Bootstrap and also using something called Jekyll and Markdown. And that's hosted on GitHub pages. We're also going to be using a tool called Postman. So this is a free piece of software. It runs on Windows, Macs. I don't think it runs on Raspberry Pis, but we don't need it to. And this enables us to test APIs. So those application programming interfaces that will give us some data, we can use Postman to post messages and get data back. It's really, really great for doing that. And we can save those scripts as kind of testing, and it just helps us develop the software. We're going to be using the Raspberry Pi and Raspbian. So whatever the latest version of the Raspberry Pi OS, that's what I'll be using. So I flashed one just before, so we've got a nice fresh install. GitHub, I'll be using that for source code control. So I always put my source code available on my GitHub repository. So it's www.github.com/Kevin McAleer, and in there you'll find all the different repositories. So the one for this one is called Python AI. So if you go to /Kevin McAleer/Python AI, you'll find the code there right now. And then we'll be using Python version 3. So whatever the latest version of Python is, more or less, I think 3.7, 3.8, 3.9, that's what we're currently using for Python. And I'll be using Visual Studio Code on the Raspberry Pi to develop the software as well, because that integrates nicely with Python, integrates nicely with GitHub, it runs on the Raspberry Pi, it's everything that we need. So that's what I'll be using there for software. Okay. So we talked about how we're going to add skills, or we would like to be able to add skills. So what do we mean by that, and how are we going to do it? So we're going to create a framework for extensibility. We're going to create a class that has a name, has a description, it has one or more actions, it has a version, so we can version control it. That'll return a success or failure status, and they probably have a web user interface as well, so that we can tweak settings and do things with it. Not too dissimilar from the Amazon ecosystem thing that I can't mention because I think it's set on my shelf over there and will respond. I do happen to have all three. I've got the Google Home one, the Apple Siri, and the Amazon one that I can't speak its name, like Voldemort. So we're going to create a class that's going to contain these things, and then as we create a new skill, we just inherit that class and we just fill out the options there as we build it, and then we can add that to a list of skills that we have available. And when we do our main loop, when the command comes in, we can check, does any of the skills that we have that command? So that'll be part of our loop that we'll be developing. So the cool bit, the speech engine. This is a bit I found so fun doing this. So on the Raspberry Pi, there's a couple of prerequisites we need to make sure we have installed. So we need to make sure port audio is installed, and eSpeak is also installed. They're two prerequisites. So you can do that by just running the sudo apt-get install command with either put audio or espeak at the end. Once they're installed, they don't take very long to install, everything else should be a piece of cake. The other thing we're going to be doing is creating a virtual environment. So this helps keep all the things that we are working on together in one place. It makes sure the version of software that we're using is all compatible. So if we're using eSpeak and we're using Python text-to-speech 3 and we're using speech recognition, all the different versions of them need to play nicely together. And by using a virtual environment, that ensures that that's the case. And what we do to create a virtual environment is we just run this command sudo python3-m and then venv and then venv, and then to activate it we use source. So we say source activate, sorry, it's not activate, it's just source, and then venv bin activate. That will actually activate the virtual environment, and to deactivate it, you simply just type deactivate. We'll have a look at this as well, just so in case there's a lot of information coming at you here. Okay, and then we need to install some packages. So I'm going to show you the easy way to do this. So we can either manually install these things by going pip install pyaudio, pip install speech recognition, pip install Python text-to-speech 3, or I've created a file in that Git repository that's called requirements.txt, and if you do pip install -r requirements.txt, it will grab all the requirements and install them for you, and it'll just work. So this is a much easier way to get up and running. But they're the three components that we need to have to begin with. When we start looking at things like Flask, we will also need to include pip install Flask as well. But we'll get to that when we get to that. Okay. Demo time. Oh yes, oh yes. So let me make sure we're all good to go here. I'm just gonna get the Raspberry Pi environment up here. Okay, so if I press that, in fact, is that's better. We can either have me there in the corner, or we can have the more zoomed in version. I don't mind which. It's zoomed in enough that you should be able to see what's going on. So what we will do, I'm just going to pull up my other code just to one side so I can see what we're doing. So what we're going to do first of all is we are going to, there we go, I was pressing in the wrong window then. I thought, why is it not activating what I needed to do? The first thing we're going to do is create a new file, and we're going to call this one ai.py. So this is going to be our core code, and then in a minute we will then create another file which we can create to do the wake words and all that kind of stuff. So first of all, in our let's arrange my window so I can see a bit better here. I've got a great big microphone right in front of the window where I want to see what's going on. There we go, that's better. Okay, so let me just tweak that a bit more, and then we can get started. So the first thing we're going to do, I always think it's a good idea to sort of name the files that you have and give yourself a bit of a reminder of when you created this. So I'm going to use the that's not the right button. Let me go back there again. Oops. Because I'm using VNC, Virtual Network Computing, I'm not using the exact keyboard. I'm using a Mac and then VNC, which is this viewing software, to connect to the Raspberry Pi. So when I'm trying to press a button, it's like, nope, not recognizing that, which is really helpful. So I just need to find the right key for all. Let's just get to the other bit instead then. Class. So we're going to create a class. We're going to call it AI, all caps, and we're going to start out with. Let's have a look. Let me bring up the right file as my reference so I can see what we need to do. So let's start out by giving this a name. So name. So double underscore name, and I'm just going to make that equal to nothing to begin with. And I'm also going to create a little array that's called skills that's going to be empty as well. That's what them double brackets mean. And then we're going to have an initialization function, a constructor. So we always use self when we're inside a class, and we're also going to pass in name equals none. So if nobody passes a name in, that's fine. We'll just default to a default name that we'll choose in a second. So what we need to do, do I need to back up a second, create the virtual environment? So I've already created a virtual environment. I'm just going to show you how I did that, just because I'm aware just launched into this and I've not even shown you how to do that. So let me just do that very quickly. So if I go into my documents folder, and if I just create a new folder, let's just go into new folder. Right, so if I do Python 3 -m vnv vnv, so that's saying run the Python 3 because Python 2 is installed on here as well, and we don't want to run Python 2, we want Python 3. -m is we want it to make a virtual environment, and venv is the command to do that, and then the name of the virtual environment is the last part, which is venv, so virtual environment. So when I press that, what it's going to do, it's going to grab all the Python files and put them in this folder that's called venv. So if I list what's in there now, there is a venv folder. So that exists, and to activate it we type source, and then if I just type v and then tab and then b and then tab and then a and then tab, it will fill out that command for me. So what it's done there is it's done source space venv /bin/activate. And you can see now at the beginning of our command line, we've got this in brackets venv. And if I type Python without any version, it's launched whatever the latest version of Python is on this Raspberry Pi, which is 7.3.3. Sorry, 3.7.3. So there we go. That's how we create a virtual environment. Now, if I type deactivate, it will deactivate it, and you can see it's no longer got that virtual environment. And interestingly, if I type the word Python here, just like I did before, but I'm not inside the virtual environment now, it will actually launch version 2, which is the wrong version, and all the libraries won't work. So that's why one of the reasons why we use virtual environments. It means we can keep our code really together and compatible and so on. Okay, now the cool thing about Visual Studio, which I've already got launched here, I went to the preferences and recommended software, and in there there's a programming section. So this is on the Raspberry Pi itself. You can see the little Raspberry Pi icon in the corner there, and this is just a Raspberry Pi 4 that's sat on my desk. You can probably see it just there, and I've just got the microphone plugged into it there. So let's get back over to the so it's just doing its install packages thing, finding all the latest versions and whatnot. And in there, there's a section called Programming, and if I scroll down to the bottom of that list, there is one that says Visual Studio Code. And that's what I've installed. So I've just ticked that box. That's what this is here. I've then gone to File and Open and found the folder that we created, which is the Python AI folder. And it actually knows that there's a virtual environment. That's what this little thing here means. It knows that we're inside that venv, bin, and Python. So it's using the correct virtual environment settings. So there's quite a lot going on there, but this is how I did say it was an intermediate level. So hopefully you should be able to keep up with that. So we're creating our AI class, we're creating our constructor, we've passed in name as nothing, and one of the first things that we need to do as an import statement at the top here, we need to import Python text-to-speech x3. So that's Python text-to-speech, x means version 3. Now, my version of Python knows this. I can see it's auto-completing things there. Now, when you come to this, you'll be like, but Kevin, I've tried this and it says it's not found. So if we go back over to our little virtual environment there, I'll just zoom that in a little bit on that one that we created there. If I just do a list, we can see that we're not activated. So let's just do that source command again. So this is b activate. And then if I do pip install, I can then make sure I get those libraries installed. So we need to install Python text-to-speech x3, and we also needed to install speech recognition as well. So it says it's installed that now. So if I now go back and do speech recognition, like so, it will go and grab that as well. Okay. Okay, so Noah says he's got to go, but I'm loving the your profile picture there. It's just a piece of cheese. Laura says this is way above my head, but you're making it look so easy. I did say it was an intermediate level, so it is. It is quite advanced stuff, this one, I'll not lie. Cool. So that's installed the libraries that we need, and that means that when we type things like import, we'll not get any weird error messages and it'll understand what we're doing. Okay. So inside our constructor, what we need to do next is we need to set up some things. So let's do self.engine, and let's make that equal Python text-to-speech x3, and then we're going to do an init command. We're going to initialize it. Next, we are going to do self.r, which is going to be our recognizer. And let's just go actually to the top here. We need to import our speech recognition. So import speech underscore recognition. There we go. And now we can do our self.r equals, I'm jumping the gun there. So when we import it, instead of having to type in speech recognition, which is like a really long string to type, we can just say import it as SR. So instead of having to type speech recognition, we can just type SR now. So if we do SR.recognizer, there we go, recognizer, and we just do that, and then we'll do self.m for microphone equals sr.microphone. And that's just going to pick whatever the default microphone input is. If I go up to the top of the screen here, I right click on there, I've got audio inputs and audio outputs. So this USB audio device is this this nice little microphone that I've got here on the stand, and the speakers are it's just the audio jack. So I've got some truss speakers plugged into that as well. Okay, so that's the first bit. That's going to initialize our speech engine, and we'll be able to hear it very shortly. So the next thing we need to do is we need to say if that name that was passed in, so this is the name of our AI, is not none. This is what I love about Python, it's like almost English. So then we say self.name, which is our hidden internal variable there. We're going to make that equal to whatever is passed in there. Okay, so now we want to have some code that says print listening, like that. And what we're then going to say is with self.m, so with the microphone that we've just connected to as the source, then we want to do recognize, so the r.adjust for ambient noise. So this is really clever, this. What that's going to do, that's going to take a sample from the microphone for about 2 seconds, and it's just going to normalize the level. So if you've got loads of background noise, it's going to sort of bring up its squelch, its threshold of where it starts listening to things above that level. So that's what the adjust for ambient noise is. That's a very clever piece of piece of technology. Okay, so that's all we need to do for our initialization routine. Next, what we will do is we can do some getters and setters. These are quite quick to do. So we've got the name. I want that to be a property. So I want to be able to just sort of say ai.name equals Kev or Alf or whatever. I quite like Tom's Alf as the name of the AI, I'll not lie. So Tom, I think you've won that one. So how do we do properties? We type the little @ symbol and then we do property. And then we just create a normal function underneath that. Oops, more fingers and thumbs here. So underneath that we do def, then name self, and we just return whatever is in our self._name. And then the setter is pretty similar to that, so that's name.setter. And these are called decorators if you've not come across these before. And what's weird about decorators is you can have the function with 2 names, but they do different things. So this is also going to have self, but this is also going to have a value. That's going to be the value of the name that we're setting it to. So let's just say self.name equals value, like so. Okay, so that's our getters and setters. What do we need to do next? What we can also do in that, as well as just setting it, we can actually get it to say something. But we need to create a function in a minute that's called say, just to make the whole speech thing easier to use for ourselves. But when we set a name, it'd be really nice if it sort of says, hello, my name is. So let's do sentence equals, hello, my name is, We don't need that space. Python's clever enough to put one after this. And then we can do double scorned name, like so. And then to make it say this, this is the first bit of code that you'll have seen that makes something say something. So self.engine.say, and then we're going to get it to say the sentence that we've just created. Now that won't actually make it say anything. If you just do that, you'll be like, why is it not said anything? You actually have to make it run and wait. So we have to do engine.run and wait, like so. And what it will do, it will then look all the things that have been passed into it to say, and then it will say them. Okay, so let's create another function that's called say. So anything that we pass into this, so let's use that nice word sentence again. I thought that was quite useful. And we are basically just going to get it to do exactly that code there. So let's just copy that. And then let's just paste that in there. Okay, and then we can have another one which is listen. Okay, so listen. Oops. And all that listen is going to do is it's going to listen to command, and this is the first time you'll see how we get it to return a piece of text. So say something, and then with self.m, remember m is our microphone, our source. Oops, why did it capitalize that then? It's really unhelpful. And then we're going to say audio equals self.r.listen and source. Oops, that should be inside of that bracket there, like so. And then once it's got that piece of text, we're going to make it say, oops, I'm struggling here, got it. Okay. Now, we need to wrap the next piece of code in a try except block, because if there's an error, and sometimes this can happen when you connect into an external web service, you know, there might be an internet problem, their service might be down, there might be a long delay, whatever. We need to handle that error. So we're going to have a try catch block or try except block. So we're going to say try phrase equals self.r, which is our recognizer, and then we're going to say recognizer. Oh, recognize, making sure I spell this right, Google, and then the audio that we captured a second ago, and then we're going to say show all equals false, and then we're also going to pass in what language we're using. So if you're not using English, this is where you can actually get it to pass in what language you're using, and I think there's like 20 odd languages that Google recognizes, maybe more. It's all of them really. So I'm going to use EN-US. I could use GB, but let's just use the US for now. I'm just going to make sure I've typed that right. So recognize Google. Okay. And what we're then going to do is we're going to get it to actually say that back. So let's say sentence equals got it, you said, plus the phrase that's been returned. So that one line there, that phrase equals self.recognize Google, that's the piece that does the speech recognition for us. It's as simple as that. So after we've done the phrase, we've got a sentence there, so we just need to do that bit again up above, which is those two lines there. So let's just copy that again. Control C, scroll down, oops, put that line just there. So it's going to listen, it's going to get a piece of text, it's going to say, got it, you said, then the phrase, and then it's going to say it, and then it's going to run and wait. So that's if everything works well. So if everything doesn't work well, we get an exception. So we can say except E as error, which just means pass whatever the error is into the variable E. So we can say print, sorry, didn't catch that, and then let's just pass in E at the end just so we can see on the terminal what the issue was, and we can also get it to say this as well. So engine say sorry didn't catch that. And then engine.run and wait. Run and wait. Okay. If everything's gone well, we can then say, you said, and then the phrase. And then let's just have the next block. So, do I need to go into that? Do I need to leave that? Let's leave that as that for now. And what we can now do is we can use this. So let's create a new file over here. If I get to the right screen. And I'm going to call this one Alf. This is going to be the name of my robot, my AI. So I'm going to import AI even. Let me just bring up the code to make sure I'm doing this right. And this is where it gets nice and simple to use. So let's do from AI, import AI instead, actually. So from AI, import, and then it's capitals because it's a class. Now, there's another thing I want to make sure we've got installed. So if we go back to our terminal for a second, I'll just zoom in on that again. So there is actually a Python library for jokes. So if we do pip install pyjokes, what that will do is it will install a library that enables us to get one-liners just like that. And we can use this to build, I don't know, a bit of fun into our demo program just to see if this is actually going to work. So let's go to the top here, and I'm going to do, just import pyjokes actually. Import pyjokes. Okay, let's do that. And we're going to say alf equals AI, just like that. Now let's make a little routine that gets us a joke. So def joke. And what we're going to say is funny equals pyjokes dot get joke. And then we're going to print that joke. And we're also going to get it to say that. So if we just do alf.say, that little function we made earlier, it should actually say something. Okay. And for our main loop, let's just create a nice simple thing, shall we? So we're going to say, command equals nothing. And we're going to say while true, and command is not equal to goodbye. That's going to be our exit, so we can exit from it. We can say command equals alf.listen. And let me just double check that we did return in the listen function, because I'm not sure we did. So let's just make sure on the bottom of that we have return phrase, like so. Otherwise, that won't work. So I'm going to save that. Okay, back to alf. So that means that whatever we get passed as the phrase is going to end up in command, and then we can do a check. So we can say, let's print command was, and then command. And now we can say if command, and this is the bit we're going to replace with Elastic Cloud, because this works fine when you've got a very specific command. This is just so that we can test it out. So this is where our skill would be, and at the very end, if we've exited out, we want alf to say goodbye. Okay, right. Let's see how badly this goes wrong when I press the run button. So I've got some speakers set up over here. I've got them on full blast. I'm just hoping that the microphone that you're listening to will be able to pick up what it says. I could actually move these a bit closer to it, actually. I'll put it right underneath the microphone. You might hear some crackling sounds. That's from the processor noise, because these are not very high quality audio items. These are literally the cheapest ones man can buy. Right, so I'm going to press. There we go. So first of all, it can't import AI from AI. So why is that? Let's have a look. So class is AI. We've said from AI import AI. So why is it not happy with that? Can't find the module in there. That is weird because it is in there. Let's make sure we've saved it. Let's try again. Okay, and then there's another one on which line, line 50 in our AI, which says return phrase. It can't do that because it's outside. It's probably the indentation's wrong. So let me just have a quick look at that. Yeah, so what I've done there, where I've got, if I just expand the screen slightly so you can see what's going on. Let's hide me a second. And if I just hide this here as well. In Python, your indentation has to be correct, otherwise it doesn't work. Where I've got that def, everything should be indented along that line there. And I've got two lines, well, a whole block of code there that isn't indented. So if I hold down Control and the square bracket, it should indent it slightly. It should enable it to sort of just move it across like that. Okay, so that looks better now. I'm just going to do Control S to save it. I'm going to go back to our ALF. I'm going to run that again to try and deal with whatever the next problem is. Hello.
Got it. You said hello.
And it works. Tell me a joke.
Got it. You said tell me a joke. Why did Microsoft name their search engine Bing? Because it's not Google.
What? Tell me a joke.
Got it. You said tell me a joke. An SEO expert walks into a bar, bars, pub, public house, Irish pub, tavern, bartender, beer, liquor, wine, alcohol, spirits.
Get it? Because it's SEO. Tell me another joke.
Got it. You said tell me another joke.
That's not going to work, is it? Because it doesn't know how to interpret other commands. Tell me a joke.
Got it. You said tell me a joke. How to explain the movie Inception to a programmer. When you run a VM inside another VM, everything runs real slow.
One last one. Tell me a joke.
Got it. You said tell me a joke. There are 10 types of people. Those who understand trinary, those who don't, and those who have never heard of it.
Goodbye.
Got it. You said goodbye. Goodbye. I'm going to sleep now.
There we go. We've just built our own AI virtual assistant, albeit quite basic. It has one command at the moment. Well, two commands. You can either say tell me a joke or you can say goodbye. But the structure is complete. All we need to do is just fill it out. So we'll be looking at the next couple of weeks at adding skills in there, so we can get weather, we can look at our appointments, we can have a to-do list, all those kinds of things, and we can make it so that we can go onto a web page, we can type in a to-do item, and then we can ask the assistant to sort of say back to us what the things are on the to-do list that we haven't completed, for example. So all those things are extra skills that we can have. We need to move our jokes one into a skill as well. So we need to build that skills framework, we need to add the joke to it, and then make it so that it can find those commands in a much more fuzzy way. So using something like Elasticsearch, which can give you a level of confidence. Now, one of the things I can show you on here, which is really cool. So if I just go back to this command line for a second, if I just go into Python, and if I do import AI, let's try that. Oops. Not sure what that is. Something about falling out of a window again, is it? We have a cat that loves to fall out of windows. Okay, so I'm getting distracted now. Import AI. So it's imported everything in the AI. And what I want to show you is the speech thing. When we send some speech off before, sorry, we just need to make sure that stops saying that. How do we set do not disturb on a Mac? Something like do not disturb. There we go. For 1 hour. Perfect. Cool. What we said, let's go to the code actually. We can see in there. There was a command which was show all is false. If we actually set that to true and we run our code again, it will actually return all the possible options with the level of confidence for what it thinks you've said. So this is quite cool. I'm not sure this will work if I if I just quit out and run it again, but let's give it a go and see what happens. So if I just run ALF again. Hello. Hello.
Got it. You said hello.
So let's try a different one. Something really long.
something really long.
That's not really doing what I wanted it to do there. The other thing I found as well, yeah, sometimes it comes up with this weird error message. It says E is not defined, so we need to improve the code and the error handling a little bit better. And I found as well that because there's some background noise sometimes, I mean, it's quite quiet in here, there's pretty much no background sound, but I have to do this like sound, and it spikes the audio, and then you can say command after that, and it works every time if you do that. If you don't do that, sometimes it just seems to sit there and not do anything. And maybe there's a setting in there we can adjust. You can make it listen in the background, so that's something I want to look at further, whereas it's actually stopping the code at the moment and waiting for that command to be you know, for some audio to come through, and then it processes it. That's not going to work if we've got a web page. We need it to sort of run in the background, and these things work asynchronously. I'm just thinking, is it worth actually showing you that thing? So yeah, we can do it really quickly. So let's just go back into Python. If we just do import Python text to speech, and we also import speech recognition, and let's just do what was in the initialization thing, which was all about the. So let's just do R equals speech recognition dot recognizer, and then M equals speech recognition. This is why we typed as SR before, because then you'd have to type all these things out in full. Okay, and then what we then need to do is we just need to get it to listen to some text. So let me just find the code to do that. Right, there we go. So if we just do with M as source, audio equals r.listen source, hello, hello. Okay, so that's listen to that. So that's now stored it in the audio. Audio, if we actually look inside there, so if we just have a look what actually audio is, it's a class speech recognition audio data. So it's loads of our wave data that we looked at before. It's just loads of ones and zeros. Doesn't mean anything yet. So we need to send it off to Google, get it recognized, and bring it back. So that's what that phrase thing does. So when we do r.recognizer, recognize Google. So we're using the Google search engine. We pass in that data, the ones and zeros. Now this is a bit I was talking about before. If we do show all equals true, and now we actually look at, we just print out phrase. Look what we've got there. We've got alternative transcript. Hello, confidence is very high, so it's nearly 1. And if I just move me out of the way for a second, you can also say hello, because I speak with a Bolton accent where we flatten our vowels. Hello. So it gives you more versions of it. If I say something else, let's just go back up there and do that. This is a really long sentence. And we just pass that into the recognizer and then look at the phrase. You can see there it says this is a really long scent. This is a ring along center. This is a really long center. This is a ring along center. So it knows what it actually is. This is a really long sentence. Well, cent, because I mustn't pronounce sentence properly because that's the one with the highest confidence. But all the alternatives are there as well. And that's what's quite cool. It just picks the one that it's most confident in. And that's what AI neural networks will provide when you send them something. They'll give you a whole list of things that it could be, and the one that's the highest certainty, the highest probability, is probably the one that it thinks is right. So you don't need all the rest of them, but just thought I'd share that one because that was quite a cool thing. So let me just have a look at the comments and see what else you guys have been talking about while we've been building that. So let's have a look. So we were talking before about the Rock 64. So Adam says, I've seen that, but I don't own it. One of the things with these boards, so there was a bit of a trend a while ago to bring out, everyone was bringing out their own single board computer, each with their own tweaks and optimizations, and that's all well and good. But standardization always wins with these things. The reason the Arduino is as popular as it is because it's a standard platform, and everyone can write their own libraries to that platform, and because there is a standard, people can rely upon it, so it becomes really popular. If you have something that's niche, it's less likely to become mass popular. So for example, my friends in the fourth group, they're trying to get the fourth language used on embedded chips, and that's going to be a bit of an uphill battle because there isn't as big a community around fourth as a language, particularly as a niche around that on embedded devices. So getting people to write device drivers and stuff, they're going to do all that work themselves. Whereas if you look at something like MicroPython, that's really taken off because it's already working on a standard thing like Python. It's just enhancing that. There is a standard that's out there, they do develop it, and then now you've got the people like Raspberry Pi organization, Adafruit, Pimoroni, they're all, you know, centering around this one standard and building it out. Yes, the Adafruit have their own CircuitPython, which is a bit of an offshoot of that. I wish she hadn't have done that, to be honest. But we'll see how that pans out, shall we? My theory is that won't work long term, and they'll probably ditch it. So Marcel's just saying hi to Linus, and he's saying hi back. We've got a bit of a community going on, which is really cool. And I think this is one of the highest numbers of people I've had on a stream at one time, actually. I'm using Restream, so it streams out to both Facebook and YouTube and Twitch and Twitter. I'm not sure if Periscope's still live anymore. Philip says, maybe it'd be interesting to use EMG sensors for Remove, just like Alex Lab, using them for his Iron Man suit. Cool, yes. I'd be interested in all different kinds of sensors. I've played with all the basic ones. I was quite impressed with the laser rangefinder because of how small it was and how cheap it is and how reliable it is. So Kang says you should have a Discord page. I'm sure your channel will reach a larger audience base. Right, so I don't get Discord, if I'm honest. It seems like you create like a little cave of your own and you have to invite people into that to speak. And I don't have a great deal of, I don't allow myself a great deal of time to chat and talk. So I tend to be building stuff or making more content or buying Sharpies, clearly. So I don't spend a lot of time hanging around in communities. The only one I do is the one I built, which is the Small Robots community on Facebook. You'll find me in there almost all the time. I'm just constantly accepting new people in and banning people who keep putting up stuff they shouldn't. So Laura says these are fun. And you're a mum from Indianapolis. Awesome. For some reason, if you've not allowed Restream to know who you are, it just says Facebook user, which is great because I don't know who you are. I'd have to go over to Facebook and see who you are. You're saying this is so above your head, but it makes it look easy. And it has your attention and you know you're a pre-beginner. So Tom has a smiley face there. So, yep, you need to indent your try-catch in one. Absolutely correct. So we did that and it worked. Didn't expect it to be that easy, right? That's what I thought. I thought this would be a really difficult thing because, you know, somebody said, oh, Kevin's just nonchalantly saying, I was going to build my own AI just in 1 hour. Done. Next. I've cheated. I've used somebody else's AI. I'm just sort of sending it stuff and getting it back. But this is what it's all about. That's all that an Alexa is. That's all that a Google Home is. That's all that a Siri is. Somebody's built the APIs that does all the clever stuff, and you know the actual loop that listens for text and listens for speech, converts it to text, and all that kind of stuff. Pretty simple, really. So Leroy says, "Awesome stuff." Is Dan going to need poop? What was that? I don't think that's what she said, was it? I've got to check this now because if that's what she says, that's hilarious. She might have said that. I don't know. Maybe I'll have to go back, Aaron, on the... Can I edit that out afterwards? Cool. So, Kevin, thanks for the experience. It was cool. Good job. Thanks, Doc. Is that fourth? I think that might be some fourth going on there. Awesome. And, oh, God, don't read my comment. Oh, that's funny. So the other thing is as well, don't Google Rocco's Basilisk. I'm just saying now, don't Google that. You can't unread that once you've read it. Right, so you're viewing from Nigeria. Awesome. Nigeria is a beautiful country. I've been there just once. the food there is amazing. There was a Nigerian jerk chicken that I had, and I have dreams about it. It was just so amazingly nice. It was like rice mixed in with some spice with chicken. Oh, so good. So good. Cool. Okay, so I think that's it for today. I think next week we'll be following this up. We'll be adding some more skills. We'll be building that out. But I think we'll look at the weather skill because that's quite an easy one to do and it's quite useful. And we can build it on top there. And we can put it into something like our in move there, so he can be the face of our AI. Otherwise, it's just a Raspberry Pi and some cheap speakers. Here's my cheap Trust speaker. That's the thing that's doing all the little crackling thing, and an even cheaper microphone. But hey, it works. So yeah, hopefully you enjoyed that, and my artwork as well. I think I'll stick to robotics. I'm not an artist. But yeah. So thanks for watching. I shall see you next week, and watch out for the midweek video too.